Alright, welcome back everyone. In the last video we looked at trying to prove two triangles congruent, and we looked at three methods that we could use to prove triangles congruent, right? We learned about side, side, side that shows that two triangles are congruent if all their corresponding sides are congruent. We looked at side, angle, side, which says that two triangles would be congruent if we can show that two pairs of sides and the included angle between them are congruent. And lastly, we looked at angle, side, angle, which says that two triangles would be congruent if two pairs of angles between them are congruent along with their included side. And in those problems, proving the triangles congruent was our end goal. That's what we were trying to get to. But in this video, in this section, what we're going to be doing is using the fact that two triangles are congruent to show that parts of those triangles would then have to be congruent. So in other words, we might be trying to prove that two segments are congruent or that two angles are congruent. Like for instance, if you look at example 1, and there's probably a change you have to make on your note sheet here. I had a typo on the note sheet. But in example 1, what we're trying to do is prove that segment AB down here is congruent to segment DC. So we're trying to prove that two segments are congruent, and we're going to do that by proving that there's some triangles in this picture that are congruent. So the three-step kind of method that we're going to be employing is we're going to, if we're trying to prove that these two segments were congruent, we're going to first identify two triangles in which the two segments, or maybe you're doing it with angles, prove that, or identify two triangles in which those segments are corresponding parts. So hopefully remember what that means, what it means for two segments to be corresponding parts. So if we look down here, triangle ADC and triangle CBA would have DC and AB as corresponding sides. So that's step one, identifying that these two triangles would use these parts as corresponding parts. The next thing we're going to try and do is prove that the triangles are congruent. And the reason why we want to do that is because once we prove that the triangles are congruent, we can state that these two parts, these two segments, are congruent because by the definition of congruent triangles, all the corresponding parts are congruent. And so the reason that we're going to end up using, and you're going to hear this a lot, so it might sound a little bit weird right now, but the reason is called CPCTC. Now what that stands for is that corresponding parts of congruent triangles are congruent. Left out my R. Congruent. There we go. Corresponding parts of congruent triangles are congruent. CPCTC. So, in other words, once we know that these two triangles are congruent, it opens the door of saying that any of the corresponding parts are going to be congruent, right? So in example 1, we're given that, first of all, segment AD is parallel to segment BC. So these two are parallel, and that segment AD is congruent to segment BC. And we have to prove that AB is congruent to DC. So let's look. Why would they be telling us that these lines are parallel? What's important about that? It's obviously important that these are congruent because that's a pair of sides between these two. And we might also notice that I have segment AC here that's a segment that's used in both triangles, so it would be congruent to itself by the reflexive property. But what's important about these segments being parallel? Well, we learned that if two parallel lines are cut by a transversal, like segment AC, then we have some congruent angles that are formed. Specifically, this angle right here, angle 1, would be congruent to this angle right here because they're alternate interior angles. And now look what we have. We have two pairs of sides on one triangle, congruent to two pairs of sides on the other triangle, and the included angle is congruent to the other included angle. So we could say that these two triangles are congruent by SAS, which would mean that all the other parts are congruent because once we know triangles are congruent, then the corresponding parts are all congruent. So let's write that out. Let's try and put that down as a proof. First of all, let's go ahead and say that segment AD is congruent to segment BC, and that is given. Let's also say that segment AD is parallel to segment BC. That's a given statement. We could have combined those in one if we wanted to. Now, why is it important that they are parallel? Well, the next thing I'm going to say is that if these are parallel, then angle 2 is congruent to angle 1 because alternate interior angles are congruent if the lines are parallel, but I don't usually write that last part. I can just say alternate interior angles are congruent. And then I also know that segment AC is congruent to itself by the reflexive property. And so what that means is that triangle ADC is congruent to triangle, so an ADC. I got to be careful. Sometimes these pictures are a little bit hard to identify what corresponds to what. What corresponds to A? Well, A is the vertex of angle 2, which was congruent to angle 1. So A would correspond to the vertex of angle 1, which is C. And then I went down the side that was parallel to get to D. So I'm going to go from C down to B, and then over to A. So ADC is congruent to triangle CBA, and we said that was because what we have is one pair of sides, a pair of angles, and another pair of sides, and the angles are the included sides between the included angles between the sides. So these two triangles are congruent by SAS. Now, once we know that these triangles are congruent, we could, if we wanted to, say that this angle right here is congruent to this angle right here, because those two are corresponding angles between congruent triangles. So once I know the triangles are congruent, I could say that those angles are congruent if I wanted. I could say that angle B is congruent to angle D, because they're also corresponding parts of these two triangles. But most importantly for this proof, what I can state is that DC is congruent to AB, because they are corresponding parts, right? DC right here, AB right here, they're corresponding parts of these two congruent triangles. So that's what I'm going to say. I'm going to say that AB has to be congruent to DC because the corresponding parts of congruent triangles have to be congruent. I abbreviate that as CPCTC. Corresponding parts of congruent triangles have to be congruent. So a little bit longer proof right here, but the idea is that we use these two congruent triangles to say that these two segments had to be congruent. Let's look at another one. In this one, we are supposed to prove eventually that angle W is congruent to angle Z. So I'm going to put the question marks there saying that's what I'm trying to prove. What do I have at my disposal? Well, I have that WO is congruent to ZO, and I have that XO is congruent to YO. And I might also notice that I have some lines making an X here, and so I know that these vertical angles here and here would be congruent. And so why is all that important? Because now I have two pairs of sides, and I have the included angles between them all congruent. So these triangles have to be congruent, and if the triangles are congruent, then any of the pairs of corresponding parts will be congruent. So our plan is going to be to say that, first of all, WO is congruent to ZO, and that XO is congruent to YO. Then I'm going to say that angle WOX is congruent to angle ZOY, which would mean that triangle WOX would be congruent to triangle ZOY, and if that's true, I can say that angle W is congruent to angle Z. And you'll see what I did there. I'll do that sometimes if I'm doing a proof. I didn't bother with the reasons because I wanted to get all these statements down kind of in the correct order so I could get my thinking down of why my statement that I'm supposed to prove, why that would have to be true. So I listed out all the statements. Now I'm going to come back and I'm going to do the reasons. Okay, why were these things all congruent? Well, that's the easy one, right? That was given information. Why did I know that these two angles were congruent? Oh, because they're vertical angles, and vertical angles are congruent. So why were the triangles congruent? Because I had two pairs of sides, and I had the included angles between them. So those two triangles were congruent using SAS. Once I've said that the triangles are congruent, I can now say that any other parts that are corresponding parts between them, they have to be congruent, like angle W and angle Z. They're corresponding parts between these two triangles. They have to be congruent, and my reason is that corresponding parts of congruent triangles are congruent. CPCTC, right? So not too bad there. Again, we see that vertical angles being used here. Those vertical angles that are congruent, that gets used a lot, so keep an eye out for that. In our next example, we have that we are supposed to prove, and I'll do this in yellow again, that SK is congruent to NR. And the reason why I'm putting that question mark there is because I don't want to make a mistake and use that those are congruent in my proof before I'm supposed to, right? I don't want to try and use the fact that those are congruent to prove something. I want to end with the fact that those two segments are congruent and that these two segments are congruent. So I like to put little question marks there just to show myself I don't know that yet. I'm trying to prove that. What do I know at the start of this problem? I do know that SK and NR are parallel and that SN and KR are parallel. Now remember, parallel doesn't mean congruent, so it's not going to be that easy, unfortunately. Just because they're parallel doesn't mean that they are congruent. But that's probably going to be important. Why will that be important? Well, first of all, I noticed that these two triangles in this picture, these two triangles would be using the segments that I'm supposed to be congruent as corresponding parts. So if I can prove that the two triangles are congruent, then I could use CPCTC to say that all this stuff is true. And I notice that SR is a segment that's a part of both triangles. So I know somewhere along the way I'll probably say that that's congruent to itself by the reflexive property. But now, why is it important that these two lines are parallel? Well, because if those two lines are parallel, and so if SK is parallel to NR, and SR is my transversal, angle 1 and angle 3 are congruent alternate interior angles. And if SN is parallel to KR, and SR is my transversal, then angle 2 and angle 4 are congruent alternate interior angles. So now that would give me two pairs of angles, right? The purple ones and the blue ones are my two pairs of angles, and this segment right here that's congruent to itself is the included side for those angles. It's joining the vertices of those pairs of angles. So that would be the included side for two pairs of angles. So that would mean I had ASA to say that the triangles are congruent. Once the triangles are congruent, all the corresponding parts are congruent. So let's write that out as a proof. First of all, I'm going to say that SK is parallel to NR and that SN is parallel to KR. That's important because angle 1 is now congruent to angle 3 and angle 2 is congruent to angle 4. I also noted that SR is congruent to itself. So that would give me a pair of angles here, a pair of angles here, and a pair of sides there. So I have enough at this point to say that triangle SKR is congruent to triangle, now I got to be careful, S to K to R. So S on the top triangle corresponds to R on the bottom triangle because S is the vertex for angle 1 is congruent to angle 3, R is the vertex of angle 3, so S and R correspond to each other. So triangle SKR is congruent to triangle RNS. And then once I said that, I can say that SK is congruent to NR and that SN is congruent to KR. So let's fill in the reasons here. First I had given. Why were these angles congruent? Because they're alternate interior angles. So alternate interior angles are congruent. Alternate interior angles are congruent again for 2 and 4. Why is SR congruent to itself? The reflexive property. Why are the two triangles congruent? Like I said, two pairs of angles in the included side, so that makes the ASA congruence in play here. Once the triangles are congruent, why are these parts congruent? Because corresponding parts of congruent triangles are congruent. So there's a couple more proofs on this note sheet. We'll take a look at those maybe in the next video. So for now, I'm going to call it quits on this one. Good luck, guys.